Okay, so we are going to learn what isoelectronic means. We're going to do questions 29 and 35, possibly 39, depending how long it takes. All right, so isoelectronic, iso means same. So you're going to see that word come up in several different things. That's actually a really good prefix to just know for the SATs and stuff like that. When you're trying to break down words, iso means same. So isoelectronic means same electrons. So that means we need to figure out how many, which element has the same amount of electrons. So we had to figure out how many electrons are in each of these. So first thing we need to do is figure out where gallium is on the periodic table. So gallium is right here. You can't read that, but it says 31. Because it's a plus 3, we're going to subtract 3 electrons. That gives it 28. So that means I'm going to go back to the periodic table and look for element number 28. It's right here. It's nickel. So that means gallium 3 plus is isoelectronic because it has the same number of electrons as nickel. Zirconium 4 plus. If I'm looking for zirconium, let's see, where would that be? It's actually right here. It's element 41. It's 4 plus. So we're going to do a minus 4 here. That gives us, is it 40 or 41? It's 40. My apologies. It's element 40. 36 electrons. So now I have to look on the periodic table and look for element number 36. That would be krypton. So that means it's isoelectronic to krypton because zirconium 4 plus has the same amount of electrons as krypton. Manganese is right here. Is element number 25. Oops, wrong way. We're going to do a minus 7 because it's a plus 7. That gives us 18. So I'm going to look for element number 18, which is argon. Iodine here is a minus 1. Iodine is right here. It's element 53. I did it again. Because it's negative, we're going to add the electron rather than subtracting. So I'm looking for element number 54. That would be xenon. And then finally, we have lead 2 plus. Lead is right here. It's element 82. Because it's a plus 2, we're going to subtract 2 electrons. That gives us element 80. Element 80 would then be mercury. So that's all there is to it. You just have to figure out how many electrons there are and then match up whichever element that is on the periodic table. Okay. Provide a brief explanation for each of the following. O2 minus is larger than O2. Well, negative 2 means in an anion, we're gaining electrons here. So oxygen is normally 8 electrons with 1s2, 2s2, 2p4. Well, with the ion, that 4 becomes a 6. So as we draw this out, we have 8 electrons or 8 protons in the middle. No matter what, we're going to have 8 protons in the middle. That number is not going to change. We have 1s2, 2s2, 2p4, but now we have 2s2, 2p6. We have 2 additional electrons here, which means that these protons has to attract those 2 electrons and the 1s, but then it has to turn around and attract 8 more electrons. So basically the protons are getting overpowered, and so it's less effective. So it doesn't have as much power to pull those electrons in, which is making it grow even bigger than just saying I'm putting 2 extra electrons in there. In reality, if you weren't thinking about that next step of how much power those electrons have, you might actually be fooled into thinking that it doesn't change at all because of the fact that the energy level is staying the same. But because we have to consider the effect of the protons, that's why it's growing. Okay, S2 minus is larger than O2 minus. Well, let's look at the periodic table. Sulfur is here, oxygen is here, which means oxygen with its 8 electrons, or 8 proton, has 1s2, 2s2, 2p4. Sulfur, however, with its 16 electrons, has 1s2, 2s2, 2p6, 3s2, 3p4. Notice it has an extra ring. That extra ring gives it makes it bigger, gives it more volume. In addition, of course, we're also losing 2 electrons, and we have more protons. But the biggest thing is the fact that it has more rings. So you're going to have to figure out how to put this into your own words. S2 minus is larger than K plus. If we take a look at the periodic table, here's S2 minus. This is 18 electrons here. It's 16 electrons normally, and we're adding 2 more for that 18. K is here. It has 19 electrons, and we're going to be losing an electron. So these are actually isoelectronic. They have the same amount of electrons. So what is the big difference here? Well, sulfur with its 16 protons, 1s2, 2s2, 2p6, 3s2, 3p6 now with those 2 extra electrons. And then potassium is 19 electrons. Oh, look at there. That means it has 19 protons. It has more protons, yet the same amount of electrons. The fact that it has more protons is pulling them in more. Finally, we have K plus and Ca2 plus. So we have K here and Ca here. Again, we have isoelectronic. We have potassium has 18 electrons, which is just like argon. Calcium also has 18 electrons like argon. So once again, we have the same amount of electrons. But potassium has 19 protons with the 1s2, 2s2, 2p6, 3s2, 3p6. Calcium actually has 20 protons with the same electron configuration. Since calcium has more protons, it's going to be smaller. It's going to pull it in tighter. Whereas 19 protons don't have as much power. Although they do have the same amount of electrons, they don't have the same amount of protons. Okay, I think that's good for this video. In the next one, we'll discuss 39 and 41.